your alternative to practical chemistry, this AGC question. So let's look at the part 2 of it, please. And there's something I just want to give you the general form of it. It may not be arranged the way I may put it. So anyway it is arranged, just be very careful. Just be very careful. I want to give you some basic information now before we come into this. Anytime you see something like this, barium chloride, know that the inference, what we are talking about, anything plus, like under this test, you see plus BaCl2. It means that you are going to have SO42 minus. Why? Because barium chloride is a precipitating reagent for the joints of a cis ion. So if it combines, if you give it something like this, BaSO4, which is an insoluble salt, which means there will be a precipitate, a white precipitate here. A white precipitate. I'm going to generalize that. I will not clean the board. I will just be showing you what it means. So I may have to clean this one. This is for barium chloride. If you have anything like under test, you have something like plus AgNO3, silver 2025. It means that we are trying to precipitate chloride ion, Cl minus. Cl minus, chloride ion. So anytime you see silver 2025, there will also be a white precipitate. There will also be a white precipitate. Then you have a chloride ion. This is it. AgNO3, because silver chloride is an insoluble salt. Check the previous lesson. I taught soluble and insoluble salts. So go through them. It will help you very, very well. I hope you can understand that. So these are the two basic ones that we just have to talk about. Anytime, listen, anytime, I'm just giving you as general. If you know this, you can always solve it. I'm not trying to tell you that this is exactly what you're going to expect, but I just want to give it to you so that you see it in any way that it may be put, you can get it. So anytime you see something like this, effervescence occurs. Effervescence. This is peculiar to carbon dioxide, CO2, from CO3 2 minus, carbonate 4 ion. Effervescence. Now, effervescence occurs. This CO2 is odorless. Odorless and what? Colorless. Is odorless and colorless. Now, you now come and see a plus lime water. Hey, lime water is used to verify the presence of carbon dioxide, CO2. Is confirmed. Please, you use lime water, and this here it turns what? Milky. It turns milky. So CO2 is confirmed. So we use lime water to confirm the presence of CO2. I'm just giving it to you in the general form of it. I hope you are getting it. So these are the basic things that you have to be careful about concerning these acid radicals, these basic ones. We are still going to look at more other ones. Join us tomorrow. We are still going to see more tomorrow and next, so that you can have a good result this year. Alright, so these are the basic ones. Let me just end these ones here and take the other ones for the metals. Alright, let me clean the board. Okay, welcome back. So now, for the metals, for metallic ions, listen attentively. Most of the time, I'm talking about most of the time, the metals that we talk about are the amphoterics, zinc ion, lead-2 ion, aluminium. Then other ones could be calcium and copper. These ones come out most of the time, but I want to tell you about these two before we come into these ones. How to differentiate them. They are amphoteric metals. So this one, calcium. Listen, anytime you see something like dirty white, please, your mind should go to calcium as inference here. Calcium, ion. Anytime you see like blue, most of it, I'm talking about this to be precise now. Blue is peculiar to copper. Blue precipitates that on cooling, or when it is steady, it becomes deep, or when you add the other reagents, it becomes deep. Blue for copper, dirty white for calcium, blue for copper. this one, when it burns with what? Brick red flame. Please take note, brick red, calcium, red. Alright, so now, when you now talk about this, I want us to talk about this zinc. Anytime you see something like sodium hydroxide in drops, it calls attention for zinc, lead, aluminum, even these ones, but most of the time it is these three. So you can have a white gelatinous precipitate, a white gelatinous precipitate, and it could be any of these three: zinc, lead. It could be any of these three: aluminum, lead 2 ion, or white precipitate, gelatinous or not, lead 2 ion and zinc ion. Now listen attentively. In excess, all these precipitates will dissolve. They will dissolve. In excess of sodium hydroxide, they will dissolve. But to now know the particular one that is present, aluminum, lead, or zinc, we now use ammonia solution. So let me clean this place now. So if we use ammonia solution, let me just say another portion of it with aqueous ammonia in drops. In drops, you will see a white precipitate, All these are also present in drops. So remember, in drops, zinc, in drops. But in excess, if it is zinc, the precipitate will dissolve. But if it is aluminum or lead, the precipitate will not dissolve. I repeat, if it is zinc, the precipitate, if you see precipitate dissolves, then you know that zinc is present. If you say precipitate does not dissolve, then it will not be zinc. It can either be aluminum or lead 2 ion. Then you carry out confirmatory tests for these two. Now, how can we confirm whether it is aluminum or lead? There are two things you can do. You can either use, permit me to write it here. Let me write it here. You can either use hydrogen sulfide. This hydrogen sulfide smells like rotten egg. You can either use hydrogen sulfide. If it is hydrogen sulfide and you have something like precipitate turns black, then it is lead that is confirmed. Why? It will form something like lead 2 sulfide, PBS. This is black. If it's aluminum, it cannot turn black. So when it turns black, hydrogen sulfide turns lead ion to black because it forms lead 2 sulfide. Hydrogen sulfide will make it to turn, if there is lead ion inside it, to turn black, which means lead is confirmed. If it is aluminum, it will not turn black. Or you heat it. Now, so the precipitate dissolves on heating and reappears on cooling. There is still lead that is present there. So these are the simple reagents we use in carrying out qualitative analysis on salts. We are still coming to other ones that have to do with oxidizing agents. So join us. If you have not subscribed, subscribe, join us, share this video. So we are going to talk about the use of, let me put it here, don't mind me, K2CR2, potassium dichromate 6 and potassium tetrahydromanganate 7. These two. We are going to talk about these oxidizing agents and their effects. So join us. Thank you very much, Mr. Primus Case.